All right, we're getting started. We're getting started on the stream. Let me wait. I just gotta look something up real quick. Actually, oh shit, I gotta look something up real quick. Also, I gotta fix this. I don't really like this either. I'm gonna change the properties of this camera. We're gonna zoom out a little bit. I don't like to zoom in on it. There, I think that's better. All right, let's keep that. Maintain that. Now I'm gonna have to switch you back over to my design station for the moment so that I can do this. All right, let me do this real quick. Okay, we're live. Fantastic. All right, we're gonna work a little bit on the robot, a little bit on circuits. I have a quiz tomorrow. I gotta get that shit done. All right, so back to the robot build. This is as far as we've progressed. I'll show you a little bit what I got going on. Transition. Here we go. This is it, right? We just got like a temporary wheel in place. I'm probably gonna have another one. I'm actually considering a design where I have one wheel on one side, or one wheel on each side, and a gap in the center. This would allow me to navigate my terrain far better. So as of now, the only mate that we have is a concentric mate between like this inner circle and this circle here, right? So we don't have any face constraints or anything like that. And what is this? This is like a 10-inch wheel, I believe, 10 inches. So this machine's kind of large. All right, and now the thing that I'm looking to acquire now is a rack and pinion. I have it, but right now we're still currently in an assembly. Let's go back into a part. Right, you can hear me? Okay, very well. Let's go back to our part. So let's open a recent. Do this guy. Yeah, that's it. Okay. Yeah, so there's some things that I need to do. Would I need to do that, or maybe I should build it separately? And then that's another thing we need. So let's go ahead and find, let me transition back. Let's go to, what's the website called? GrabCAD. Let's go to GrabCAD, and I need to look for, what was I going to look for? So I got my rack and pinion, and, linear guides. Linear guides. I think that's how you spell it, yeah. Is it glide or guide? I think linear guide. Lead screw driven. No, I don't want a screw driven. I just want a mechanical guide. Maybe it is glide. Steering cylinder, pneumatic linear slide. No. Let me say glide. What the fuck? Okay, come on. Linear glide. There it is. No, linear glide. Did I spell it wrong? No. Okay, I guess let's go through the pages on guide. Are you kidding me? Linear motion slide. That's pretty much it. That would be fine for a model, for a simple model. But I mean, come on. I literally just found such good ones the other day. I'm pretty sure I looked up the same exact thing. Like this, linear guideways. That's what I'm looking for, though. I mean, that very well may be the one. You know, maybe it. Alright, let's try to implement this one. Let's see how this goes. You can download it. Wait for that to happen. Okay, cool. And then we're going to implement it into the robot build. We're going to figure out exactly where all this placement's going to be. All of this, again, is a rough draft, right? We're going to have to go back and remake this model, I'm sure, a number of times. All right, let's go ahead and save that in a proper... Well, we have to extract it first into a proper location. You know, because, like, this is a rough draft, okay? I don't really, you know... it's difficult to perceive optimizations without actually having, like, a foundation, right? So otherwise it's just arbitrary, and it's, you know, there's a, you know, it's obscure, right? It's not so easily seen. So we're building a rough draft, and as we go, I can go ahead and develop the model to be more, you know, efficient and greater, optimized, and you know, amongst other things. So and what is this that we're doing right now? Oh yeah, the linear guide way. Okay. So So it's looking nice. We'll select that folder and I'll extract them. Okay, it looks like we have it. So this is what this is. This is the gonna this. You know what I mean? So that's the assembly. Let's go back to the palm bar. Here we are. All right. So let's go ahead and introduce this now file. Should I do that, or should we open this into a new? Should this be a new build? Like new part, and then we can go ahead and assemble it. We can think about things like that. Absolutely. All right, let's do it. Let's go to make it a separate part again, roughly. So new part. Okay, we're gonna do a new part, and then wait, extrude by space. No, this isn't what we want. We want to. Actually, maybe that's not what we want to do. Internet models, wheel, shock absorber, linear guideway. So we want this part, body, chamfer, guide rail. Okay, yeah, we want this. It's a lot of shit going on there. How can I get a good measurement on this? Smart dimensions. Come on, brother. $200. Yeah, this is all reference, baby. I don't want to play no games. It's all reference. Okay. 200. Is that really even important? Not necessarily. It's gonna have to be a longer run than that. I'm sure of it. How large is this? Shit. Okay, let me out of here. Let's see what he measures. Yeah, give me a front view. Oh, top view. Yes. $32. Okay. 58.8. Okay. 32, 58.8 millimeters. Wait, what are these dimensions in? What units is this? Oops, millimeters. Oh, okay. Millimeters. Alright, okay, yeah, so was this what I'm gonna do right now? I thought I was gonna do electrical homework because I got a quiz tomorrow. So I really need some practice in that. But shit, I'm about to do this now. Alright, so look over here. We're gonna do this. We're gonna draw it out and we're gonna put those dimensions on paper so I can just, reference them real easy. So 58.80. 58.80. What do we got here? 32. Right, and then 200, but that's not too important. That's not important. Oh, okay, and then let's look at the height real quick, too. Let's look at the front again. Bang. Well, are we still in a sketch? No? $12.25. Okay. $12.25. Oh, I didn't show you what I did. Okay, there. And then we did that, applied that to the thickness. Okay. Exit sketch. Alright, Butamus. So now we can implement that into our assembly. I see it has some set holes for the screws. and they're chamfered so that they set inside. That'll be perfect. That'll be good. Okay, so we'll figure out how to. Oh, I guess we can do that right now too. Let's look at the distance between the holes. Right, we want to know exactly how far these holes are apart, so that we can implement that into our build. So let's go ahead and do another sketch like this, and then I think we should be able to. Wait, that's not what I want to do. Let's do this. Yeah, like that. So from there to here. $35. Okay, 35. Oh yeah, I ain't gonna worry about that. Not until I actually build it. I don't need to worry about that kind of shit. Alright, cool. So we got our dimensions on paper. We can reference these. Now let's go ahead and open. What were we looking at? Rack and pinion. Yeah. Okay. So those are two separate parts. What are those? So that's the screw holes. That's where we attach it. Bolt holes. Is that really? Let me think. Oh, another thing we need here. Let's open that up again. We need to go back to this. And I need to figure out those holes. Which would be, what is that, like a, no, top view. Here we go. Okay, maybe we can just do a smart measurement. Give me a sketch. Give me a top. Oh, that's fine. Give me this. Give me a smart dimension. Can we do a center? Yes, we can. Can we do a center? No? We're not gonna get a center on it. Okay, that's fucking annoying. Fritz, yes, Sev, please. Oh my goodness, Fritz, I've been waiting for you. Sev. Yeah, we're doing a little bit of CAD today, figuring out the dimensions so we can implement it into the robot build. I got 25 here between each hole, and then let's figure out what the other side is. The other dimension, 25, that's millimeters we're working in. All right, let me find the center of this guy. Oh yes, Sev. Please. Man, I just don't got it like I used to. Please. Okay, we got another 25, so it's square. Perfectly square. That's beautiful. This is CAD. Yeah, I'm trying to take some measurements. This is called like a linear glide, or a linear glideway. Yeah, this is CAD. And then look, I'll show you the robot. This is the robot build thus far, and I'm about to implement these other parts into it, like this linear glide and the rack and pinion, you know, to create a rigid mechanical mechanism, right? But this is as far as we've gotten. So we have a shock absorber here, right? This is one wheel, one side. Probably gonna do another one over here, or even like, I don't know. I was just trying to find a model as close to what I could acquire in reality. So it's a 10-inch wheel. It seems to fit pretty perfectly, but I have other things to do to get it where I really want it. And then the rack and pinion set's gonna go inside of here along with the gliders to add that level of rigidity. And then a central motor is gonna operate that mechanism. And then we're also gonna have to build a mount and a motor down here to run these two wheels. that are gonna do like most of the driving. But then yeah, the rack and pinion is gonna be implemented in here to operate some arms. So that's pretty much what we're working on now, that system. And again, it's a rough draft, you know, so like there's a lot to be developed yet, and there's a lot to improve upon and innovate. So, you know, don't get me wrong, but this is essentially like, I don't know, fuck, we're kind of getting the basic fundamentals. It begins, you know, searching for trash on the street, along the street, and on the sidewalks and stuff that I could use to build this because I don't have any money. So, you know, I thought this was a non-disclosed thing. I mean, not yet. Not yet. It's not a non-disclosed thing. Plus, I haven't talked anything about, like, the purpose of it. So, I'm just simply showing a design of something, but, like, I've never discussed the purpose of it or talked about its motive. You know, so, but also it's not like on paper, you know what I mean? So until that point, until then, chilling. But you know, the final thing that I produce may not even look anything similar to this. Who knows? Who knows? But probably, I don't know. I feel as though I have like a little bit of an intuition in regard to the mechanisms at hand and like how the electronics and stuff are gonna play. But we'll take a look here. And then also I can like move things around with constraints. Like I don't know if I can move it right now. Oh, okay, I can. That's kind of fucking it up though. But eventually when I get all that and I set all my constraints, I can rotate it in ways that it is like constrained to rotate in, such as this thing around this axle here. I'm gonna have to figure it out, but there is a way to model, like simulate this spring or this shock absorber as an actual spring, right? And then we can, you know. Did you see Clav came in 8 seconds on stream with his girlfriend? Jenner, not only because of the lack of endurance, but by streaming, though. Brother, yo, that was unexpected. I didn't think I was gonna read that. That's on some pause on that shit. Yeah, that's crazy. I actually did not know about that. I'm usually pretty tuned in, you know, with the news, but that must have been an emergency broadcast, cause like holy fuck, but that's pretty crazy. 8 seconds, really? Jeez, you know, my girl would be pissed, right? 8 seconds? Are you kidding me? What a joke. Looks maxing, maybe talk about endurance maxing, you know what I mean? I mean, what a fucking joke. Alright, back to what we're doing. Okay, we got dimensions for this, so we can implement this. I'm trying to think of where we need to start. I mean, really, I would need to add the mount and things to here. So that's where we could start. We could do that, and we're going to have 2 glides. So we're going to have to think about how everything's going to play a role. But we're going to do a sketch on here, and that's where it's going to be implemented. It's going to have to go, it's going to have to go on top. How wide is that? So 32 millimeters. 32 millimeters wide, essentially. For real, my dog. For real, my boy. That's what I'm talking about. You know, big dog player, big pimp player. That's motherfucking Fritz out. You guys catch him on the Minecraft, catch him on the Bed Wars. Sev. But, you know, there ain't enough time in the day, you know, all the way to Timbuktu. Some shit like that. Bruh, I gotta stop drinking. I only drink 4, but I'm a little dizzy because of the Humski. Well, that'll do it, right? It's the combination, the killer combination, you know? Yeah, I like to call it the KK. Don't, whoa. I know what you're thinking now, okay? Alright, I know what you're thinking, alright? But refrain from finishing the phrase. But the KK, you know what I'm talking about? The killer combo, right? Get your 2-piece, right, for $5. They don't do that anymore. Now everything's overpriced, and it's fucking ridiculous. True. Alright, we're gonna have to implement this. First, let me see. So let's start a boss extrude. Wait, do we want to do a boss extrude? No, technically we'd want to do an extrude cut. So we're gonna start here. I gotta know if I have 32 millimeters. Let's see, what is 32 millimeters? 32 millimeters in inches. Fuck, I'm really fucking up. Oh, okay, here, let me transition you back. Bit boy. There we go. We got 32, 1.25 inches. Okay, so 32 millimeters equals 1.2598 inches. Yeah, we'll go to the fourth decimal place just because, I don't know, I want a high level of precision here. So we wrote that down. Let me see what we got going on. Okay. We got that, so now... Okay, let's consider let's consider the amount of room that we have here to see if we have enough space to implement this. So it's 1.2598 inches width. Let's see, what do we have for a dimension here? 1.75, so that is absolutely not even close to enough room. So what are we gonna need to do? Okay, so we're gonna need to exit this sketch. We didn't do anything other than write that bullshit dimension. We're gonna have to do a sketch here. And now we're gonna have to increase this. Is this where we want it? Fuck it, let's try it, right? Let's give it a shot. I'm not really sure if this is where I want it. Okay, so we're gonna do an extrusion. We had 1.75. 1.75, let me see. Well, so we have 1.25. It's approximately 3 inches of space that we need. How much of a gap should we need? For what reason do we need the gap? Because of the width of the rack and pinion? Specifically the rack, because of the width of the rack, right? You know, boys, not that kind of rack. Okay, I know where your minds are going. You're in a haze. You're in a fog. You're waking up groggy. All right, it's okay. But I'm talking about the rack to the rack and pinion. All right, I guess we can go hop over there and dimension that. Can I? Is it gonna let me? No, it's not gonna let me until I finish this. Well, we can come back and edit it, but let's say, so 1.75, we need 3, 3.75, that gives me that much room. Let's try that. Okay. Alright, now let's see if we can jump over here. Yes, we can. And let's measure the width of this thing. Technically, how's that gonna roll? So that can be connected there. That's gonna move. Well, that'll be attached to that. Yeah, that's attached to that. But it wants to attach like that on top, and then that would be like that. Okay, that's fine. That's fine. Wait, technically, no, not necessarily. Because would that even work? Let's check this out. Right, sketch. Alright, let's pull some measurements on this hoe. Alright, smart dimension that hoe. Let's see. Center. 1.25. Wait, 125. Okay, for the rack and pinion. That's a lot. That's quite a distance apart. Right, so we're writing it down, taking notes so that we can implement it into the system. Okay. All right, 125 millimeters. That's far. Exit sketch. That's 25. Yeah, 25. $25. What the fuck? Exit dimension. Wait, then I didn't get that. I didn't get that. Okay, this is tripping me out. We'll just do it like this. $24.85. 0.85, 24.85. I have that. Okay. 24.85. Okay. And that's fine. This guy. What? Why can't I do a point? What the? That's really the radius? 1,341? What? That can't be right. Whoops. That can't be right. That's huge. 52 inches. That just ain't. There's no fucking way. What? There's no fucking way. Actually, wait, hold on. There, I just don't believe it. New assembly. Let's look. Let's look. Let's bring these two parts together. That's fucking crazy if true. What the? Bro, why are you on the wrong fucking side? Get on the right side. Like, are you kidding me? This is fucking retarded. Oh, my bad. I didn't mean that allegedly, in my opinion. Bro, why can't it just look at this thing? He's at weird angles. Do I have this going on here? I think so. He's just at weird angles and shit. I don't like it. I don't like it at all. Do your move. Do your thing. Oh, do your thing. So that really is that large. Let's see in this. Let's see. Let's go here. Palm. No, that's the wrong one. This one. Models. This assembly have changed. Yes. What changed? Is a rat gonna be in there on some stupid shit? No. Looks alright. Let's get rid of that. Don't save. Let's get rid of that. Don't save. Let's get rid of that. Whoops, don't save. Let's get rid of that. Part 1, get rid of that. Don't save. Let's get rid of that. Don't save. Don't save. Alright, cool. Alright, let's insert that gear, because I truly don't. Yeah, it's not that big. I don't know why it went over there. Assembly? How do I just move shit? I know I can. Move component. Why is it saying 1000 millimeters? That's good. That'll work. That'll work in this. I don't know, it'll work. I'm not really sure why that's the case. Okay, buddy. Alright, so we can start here. I don't know, I don't trust these measurements though. Cause what was 24.85? Oh, that's 25. Shit, man. I don't know, man. Alright, let's do extrude boss base. Yeah, we're gonna keep it tight. Keep it real tight. Center line. Smart dimensions. Let's make him 12. 14. Let's make this, we'll do this for right now. We'll mirror this. So 32 millimeters. 32. Whoops, that's inches. Oh, 32 millimeters. Shit, okay. 32. 1 point here. I'll put this in copy. Come on, don't ask me. Go to the last one. Oh, fuck, don't ask me. There, like that. Okay. Check. Smart dimension that hoe. Let's go. Nah, it can't be 0. Let's do 1. That ain't really enough room though. So wait, okay. That's 25. But that's the teeth. So technically 24.85. 24.85 is this. So it's less than that. Okay. Don't make this 0.25. Something like that. Check. Smart dimension. Okay. Beautiful. Alright, 0. We want him 0. Okay, nice. Oh, what the 14? That's not it. How big is this thing? 16? There. Okay, let's do another one. Are you kidding me? Alright. 7 Illy. Good night, Illy. Good night, good night, good night, good night, good night. Good night. Smart dimension that hoe. Good night. 16. What do we do? What did we do that again? Oh shit. That was 32 millimeters. What the fuck? What the fuck? That fucking ruined everything. Are you kidding me? Watch, can I not do it now? Stupid bitch. Yeah, that's fucking right. Better believe it. 0.25. There. Okay, now. No. Wait, that's not necessary. Yeah, no fucking duh. So what's the problem? Am I still in the sketch? I am. That's why. There. Shoot cut. Okay. It's got one of those lines for reference. That's all. Wait, I can't do that. Something like that. Alright. You know, this is stupid. This isn't the way I should do it. This is really stupid. Let's do it a better way. More efficient. Alright, smart dimension. Fuck, I didn't get the dimensions of shit. What the fuck? Yo, seriously? I know I got the dimensions of something earlier. Or the diameter. But I have nothing. Now there's nothing. Okay. File open. Guide rail. Is that the one? That's the thing, though. Eight. Okay. Eight. Which is fuck. What is that? 32, half of 32 is 16, so 16. What the fudge? What just happened? What just happened? What just happened? I swear I'm always fucking always losing. My voice always gone. What are my fucking axes? Oh, there. Okay. X is this way, yeah. So it is X. Why the fuck isn't he showing up then? 1 inch. Who gives a fuck? 2 inches. No, actually, we need them every 35 millimeters. 35 mm. There, do that. I want fucking, I don't know, 6 of them. Where are they? Why aren't they showing up? Linear pattern. Check. Fucking nothing. Why? Exit sketch. Where's my shit? Do I have to do it after? So now what, do I do that and then I do a fucking linear sketch? No. No, it's gone, actually. So I edit sketch. through all. Did I just say edit sketch? No, I edited extrude. Alright, come on, brother. Don't gotta fucking piss me off. Alright, linear sketch pattern. Yeah, linear sketch pattern, yep. X-axis. It sure is the x-axis, but it don't want to fucking work. 2. Display instance count, dimension, x spacing. What does that even mean? 2. Alright, 35. Why is there nothing? Is that why entity is the pattern there? That's why. I'm a piece of shit. 10. 11. Okay. And now we want to mirror entities. Oh, but first I got to I got a reference geometry plane. This guy. If it'll let me. That guy. And then, well, where are we at? Shit. I don't even know. I really don't even know. Look in the back of him. Let's see. I gotta pull a smart dimension. Yeah, we'll edit him in just a moment. Let's see, sketch, smart dimension. Can I get a sensor here? Not even. From this guy to this guy, but I can't. Censored line. What? Nothing. Bro. 5.63, 5.63, 5.63 divided by 2, 2.815. What the fuck is going on? Exit sketch. Holy shit. I'm losing it. Looks great. Who says that? I can't read it. Sorry, everything's white as shit and I can't read it. Dino! What's up, Dino? Oh, yes. My sweet, sweet Dino. My sweet, sweet Yoshi. Oh, my goodness, yes. Thank you. Yeah, I'm trying to implement some other parts into the model, like the rack and pinion, like the linear glides, glideways, and things like this. But it requires a much more tedious process. 5. What was our 2.815? 2.815. Yeah. So that's half of that. I still ain't doing it right. Imagine we did that, because we'd have to subtract that. Okay, wait a second. Shit, this is not going good. I gotta do homework too. I gotta work on stuff. So okay. Wait. So we want to be because we want to end up right here. We want to end up right here. So from okay. So what we do? I just can't. It's like not letting me click on stuff, right? So I gotta make a new line. This is ridiculous. Like that. So smart dimension. Okay, 2.13. 2.13 to this guy. But then it don't let me pick that. Doesn't make much sense. Does not make much sense, Dino. Right, from here to here. Okay, 5.38. 5.38. So that should give us that 5.38 minus 2.13 equals 3.25. 3.25. What the shit? Wait, what? Hold on. So now puts us where? Puts us right there. From the what sense does that make? There's no way. That's the bottom of it. So this is 3.25. This is 3.25. Okay. Yeah, this is right here. 3.25. Half of 3. Okay, so 3.25 divided by 2. Brother, holy fucking shit. Okay, I'm losing it. Wait, so 3.25 divided by 2, 1.625. 2.13 plus 1.625 is 3.755. Okay, and that's exactly what we want. Now I can go ahead and say mirror plane this guy. Features, faces, bodies to mirror. Okay, and I merged them, so let's go back and not merge. Edit. Flip side. There's not a merge. All bodies auto select. So okay. Okay, there, that's what I wanted. Okay, that was efficient. Although we're not really centered up or anything, but you know, whatever. We'll really figure that shit out later. I guess this is all just rough. All right, so let's so I'm gonna save this. Save. Let's wait. That's a. Oh, it doesn't even make sense. Of course I didn't check that. Wait, right? Oh no, they're singles. Okay, so check this out. Let's go back to open recent. Let's go back to wait, do I have it open still? I do. Assembly. Yes. Check it out. We got the holes now in the assembly. It automatically updated. Now I want to insert the glide, and I want to see something. I want to see how this lines up. Insert components, glide rail. Yeah. Like that. So now I want to get concentric. Let's see, mate. We're going to concentric this guy with this guy. Right, concentric, coincident, concentric. That's what we really care about. Okay, concentric, right? Yikes, can my computer handle it though? That's the question. Alright, so we're concentric. Fantastic. Let's get another guy concentric. So we want another mate, him, and him. Bang, concentric. Yes. Concentric, yes. And then I need, oh my gosh, I gotta change this. Wait, not that. No. Perspective. This. I need to see the back side of him, right? The face. So, am I gonna be able to do it though? No. I don't know if I'm able. Yeah, I don't think I'm gonna be able to do it now. Mother trucker. I guess I fucked up the order of things. Yeah, okay. Let's do this differently. First, I'll do the face mate, and then I'll do the concentric mates, because that did not work out. All right, mate the component. We'll do this backside face with this face. Yeah, like that. Okay, that's beautiful. Coincident, yes. Okay. Concentric mating. Concentric mating right there. Get it done, sugar. Get it done, sugar. Concentric. There it is. Check. Alright, let's concentric this guy with this guy. Pause. Concentric. Alright, so we'd have one like that. Again, this is very rough, okay? So don't judge it entirely. Okay, we're done. Let's insert component. We're just gonna do the same thing, but this time we're going to flip it. Let's mate it up. Oh yeah. Coincidence. Yeah, baby. Coincident. Check it. Made it up. Concentric though. This time made it up. This guy. Oh yeah. No, not tangent. Fuck. Concentric. Oh no. There it is. Come on now, baby. Alright, concentric. Oh yeah. Concentric. Do you consent to be my concentric? Do you consent? There it is. Alright, 2 linear glides. Obviously, they'd be longer though. Of course. So I don't know exactly how we're going to achieve that, but that would happen. Okay. And then yeah. Oh, okay. And then so that would be. Oh, okay. They said that the distance between them would be determined by a very particular. It would be determined by the diameter of the gear, the distance between them, right? That's what would determine that. Okay, because I wasn't really sure earlier, but that's totally what would determine that. Okay. sure hope this works. I really wanted those below those too, so I think we have a lot of work to do still. Excuse me, but yeah, I'm just gonna save this for now. Save all. With an empty sketch, do you want to delete the empty sketch and continue saving? Yes. Because I gotta do I should do some homework stuff. Rebuild and save the document. Let's get it done. Come on. Rebuild it. Must be saved. Using this document. Save all. Bro, come on. Get it done. Oh shit, what'd I do? Okay, it's looking good though, right? It's looking alright. Fantastic. Alright, yeah, so we're probably gonna discontinue this to here. And again, like, that's not gonna go all the way through like that, those holes. Ideally, it would be manufactured for bolts. So, you know, the bolts will they'll insert into a particular depth. I think that, yeah, that would be ideal, right? Because these are chamfered for set screws. So, it's not like it's gonna be a bolt and nuts. It's gonna be a manufactured screw hole. So, it's exactly what's gonna happen here. Yeah. And then the way that we currently have it set up, so let's go ahead and imagine. Yeah, okay, I know I need to get to the homework, but let's take it one step further. Let's see if we can do this. Simulation feature. This is the assembly, yeah. Yeah, this is the assembly. Where's the insert component thing? Why am I missing this? I don't get it. What? This is the assembly. Where's the insert component thing? What am I missing right now? What the fuck? What? I guess here we go. New part. What? Oh, existing. My bad. Okay, let's browse it. I'm really fucking it up here, eh? Guide rail. It is an internet model, worm gear motor. Not quite yet. Rack and pinion. That's the one. Let's do the rack first. Except it's super long. You know, that's the shitty thing. Is that it's like it's stupid long, but we'll have to cut it down. So the idea here is to no, this is just stupid to do right now. I guess we could see, and it's literally not even like it won't work. It doesn't match up nicely. What is my vocal sound weird? Is the audio quality weird? No. No, it's okay. Yeah, okay. Alright, yeah, we'd have to cut it down first and do all that, and then I don't even know, because if it were to come this way, I wonder what other kind of rack and pinion sets there are. This one isn't great. Let's actually look at some others. Rack and pinion. Does it have to be SolidWorks tag? Just something simple like this, rack and pinion. Oh shit, that would work good. Maybe not though, maybe that's not heavy duty. Hmm. That's cool. I like the round. I like the round style like that. That's nice. What's this website? This is GrabCAD. So you get a lot of like. I mean, I made an account. I can't remember if I signed in with my school account or not. I don't think I did, but just a lot of free models that are compatible with SolidWorks in particular. I mean, I guess I got a tag here, SolidWorks, so maybe that's why. He has a good website. Has a lot of models on it. And so I can take from this anything that's like a typical manufactured item. Anything not custom to my build. But yeah, I don't know. I'm gonna have to really get on this later. Yeah, this is just too much to work with. I don't want to do all that right now. Oh yeah, it's super cool. It's super cool. Let me see. It's super cool dyno. It really is, and it's very helpful. I got this shock absorber from there. I got this wheel model from there, right? And then I got these linear glides from there. We have a lot of work to do, but I'd say it's coming together, and I think it'll actually prove to be, um, I think it'll fulfill its function. Okay, I think it'll fulfill its function, and so it's gonna work out well. But for now, I gotta jump over to circuits, right? So here, let's get a last look at this. This is the current progress of the build. A lot of work to be done, but at least we're getting a fundamental idea of where we want to go with it. And then from here, it's just all about innovation, and doing what we perceive as the best. There's many routes, and it's limited to your creativity. So essentially, you can take it wherever you want to, as long as it's within the realm of possibilities and it's rational, right? We can't just we do not govern the laws of physics, right? It is God who governs the laws of physics, and they've essentially already been established. So if you think you're gonna go ahead and break them, then you're fucking crazy. All right, forgive me for cursing, but I needed to emphasize and really convey the message. So I hope you understand. I hope you get it now through that thick skull of yours. All right, so save all. Save internally inside the assembly. The assembly contains unsaved virtual components. Yeah, let's save everything, right? Okay. Is that good? Alright, I think it's good. Let me close out of this. Let me close out of this one. Let me close out of this one. Let me close out of this one. Alright, back at it like a crack addict. Okay, let's go back to the homework and let's do some more problems for my quiz tomorrow. To be prepared. To be prepared. Alright, I don't think we did this one yet, did we? We did solve the last one though, and we got that right. So, feeling pretty good. Feeling superb. All right, so we're looking at sinusoidal like AC analysis. Determining the various values such as current and voltage of a sinusoidal steady state. Okay, and we're provided various parameters. So let's go ahead and indulge in this AC analysis. So we're given a independent voltage source right here, Vs, positive negative terminals defined. And then we have a resistor here, travels down. We have this in series with a inductor here. Okay, and then we have another resistor in parallel. What do we have? Another resistor here in a series network with a capacitor. Okay. Just like this, and this is what we're going to consider our ground or our reference node. We can draw this a couple different ways, but right now I'm going to do the little fork way. I like a little fork. Okay, so let's put down some values. We have 62.5, of course, in ohms, 50 millihenry, 500 ohms, 300, 1 microfarad. Okay, what do we know? We have 50 millihenry, we have 1 microfarad. So let's go ahead and solve for the impedances of the two, the two storage elements, right? That being our capacitor and our inductor, right? They store energy in their own respective ways, the inductor being magnetic fields and the capacitor being electric fields. So the impedance of these, respectively, ZL equals J omega L. ZC, the impedance of C equals negative J divided by omega C. Okay, and then we are provided with the value of the voltage, Vs of t, right, a function of time, equals 250 sine 2500 T volts. Okay, it might be a little hard to see, but we'll cover it. Okay, so that entails that omega equals 2500. And of course, omega has a unit of radians per second. Okay, Vs, the magnitude is 250, and we have a sine wave here. So with respect to the sine wave, we have no phase shift, but we need to put this into a cosine term. So this would equal, no, fucking negative, no, I don't think so. So it would equal 250 cosine of 2500 T plus 90 degrees, all right, V. If we put this in phasor form, so that's Vs equals Vs of t, I guess let's be specific. Phasor form, we're going to do a capital, equals the magnitude of 250, phase angle positive 90 degrees. Okay, so there's that. What are we considering? So find I naught of t, and I naught of t is right here, specified. I naught of t. Alright, so that's essentially what we're looking for, is the I naught of t. That was a little cut off. And here's I naught again, right? This arrow. This is the current flowing through the 62.5 ohm resistor. Alright, now let's continue to calculate the impedance of our respective storage elements. So we have J omega being 2500 multiplied by 50 e to the negative 3. And then down here we have negative J divided by omega 2500. Multiplied by 1 e to the negative 6. All right, we'll pull out the handy dandy calculator and we'll go ahead and buff that out. So 2500 times 50 e to the negative 3 equals 125. 125J, don't forget the imaginary number. And then we have negative 1 divided by 2500 multiplied by 1 e to the negative 6. negative 400 J. Okay, now that we got that, right, we could label those as such, but we're just gonna go ahead and move on, and we want the, right, so we can use mesh current analysis. Why not? So VS minus 62.5 I naught minus, I guess, the impedance of that. So minus, would that also be a minus? It would be if we said that the current was going this way. All right, positive, negative, current was going this way, positive, negative, current was flowing this way, flowing that way, flowing this way. Right, so we're doing the mesh current analysis, or mesh analysis, whatever you want to consider it. It's not a very good arrow. Like that, we'll call this I naught, I1, I2. Okay. So minus, no, that's not that, 125J, 25J, what, multiplied by I naught minus I1 equals 0. Okay, that's one equation. And then we have, right, the impedance, 125. Yeah, okay. Yeah, but it's all impedance, so it has to be subtraction, right? It'd be a similar thing. Okay, and then we have 0 equals negative impedance again, 125J minus 500, 125J I2 minus I1, or I1 minus I naught, minus 500 I1 minus I2 equals 0. All right, and then our last equation is going to be 0 equals negative 500 I2 minus I1 minus 300 I2 minus the impedance, negative 400 J I2, right, equals 0. Okay, very well. So we know the value of VS is 250, 90 degrees. So, okay, and then we could go ahead and we could turn that into rectangular form for the purpose of addition of subtraction. So that would look like this. That's going to be 250, 90 degrees. So we're just going to use like, what is this called? I mean, trigonometric relationships. Perhaps we consider it that. Check it out, but it's going to be like this. So 125 imaginary number is going to be, and then we have our phase angle, right? No, we're looking at VS. 250 phase, 90 degrees. So, like VSX equals 250, cosine 90 equals 0, yeah. And then VSY equals 250, sine of 90 equals 250. Okay, right. So it's purely imaginary. It's purely imaginary because if we're working with complex equations, then the coordinates would be imaginary along the y-axis and real along the x-axis. So if no part of this is real, and it's entirely imaginary. I mean, for it to be a voltage source, though, what the fuck? What does that really mean? I don't even know what the fuck that means. But it's okay. Let's move on. Let's consider it. Yeah, sure. We'll let it go. We'll let it do its thing. Yeah, I really appreciate you guys being here. Thank you so much. Let's keep working these circuits. Let's get it done. Okay, so that would mean our equation looks like this. VS equals just 250 J Okay, I believe so. That means it looked like that for real. Huh. I mean, in order to convert it into a cosine function, we had to add that 90 degrees. I mean, it is what it is. Okay. So we have 0 equals 250j minus 62.5 I naught minus 125j I naught minus plus 125j I1. Okay, we have 0 equals negative 125j I1 plus 125j I naught minus 500 I1 minus or plus 500 I2. Okay, and then we have 0 equals negative 500 I2. Again, we're just doing like distribution. We're just distributing everything out. 500 I1 minus 300 I2 plus 400j I2. Right, equals 0. Okay, we have this. So we're getting our system of equations, and then we're going to go ahead and use matrices to calculate the values of our independent variables, those which we're solving for. So we have, what are our unknowns? We have I naught, we have I1, right, and we have I2. So those are our 3 unknowns, and we have 3 equations to solve for it. Okay, and we'll separate them. Fuck, that was awful. Separate them by a line. There. Okay, do it like that. So 250j minus 62.5 I naught minus 125 I naught plus 125j I1. So 250j. So we have a constant here. Negative 250. Is that going to require multiplication though? Because that don't really make sense then, does it? Does it? I don't know. Let's figure it out. So can you see that? Yeah. 250j. 250 imaginary minus, or well, we're just going to say plus I naught, and then we'll do this. Negative 62.5 minus 125j plus 125j I1. Okay. Now we have those combined. We could plug that into the matrix, but the matrix is going to require a determinant calculation. If we're working with determinants, that's going to be a multiplication. So how the fuck, and then does that mean we're going to have to do a conversion between rectangular and polar coordinates, right? Because if we're in rectangular, we can do an addition and subtraction. If we're in polar, then we could do multiplication and division, right? This is the way that we need to manipulate the complex equations. But what the fuck, what does that mean for the matrix, considering that it employs both, in both addition, subtraction, multiplication, not so much division, right? Well, I would. So, yeah, and then the determinant. And then even to solve using Kramer's rule, I would have to do a division. And so, where does this really lead me? Because can I use Kramer's rule to solve? Maybe let's ask AI a question. Let's see if I can word it properly. All right. So, considering I have a system of equations provided by analysis of an AC circuit, considering I have a system of equations provided by AC analysis of an AC circuit, and in order to perform addition and subtraction, I require rectangular phasor form, but in order to do multiplication or division, I require polar phasor form. And when utilizing Kramer's rule to solve for unknowns in a matrix, in a matrix, the arithmetic requires both addition and and subtraction. How do I compensate for this? In like an efficient manner, right? Because I could do it and take me forever. To compensate for the conflicting mathematical needs of Cramer's rule in AC circuit analysis, you must convert your phasor values back and forth between rectangular and polar forms at each specific step of the matrix calculation. Because Cramer's rule requires calculating determinants which involve multiplying pairs of elements best done in polar form and the subtracting those products best done in rectangular form, you cannot remain in a single format throughout the process. Shit, that really sucks. Are you kidding me? Like, that's the worst thing I've heard since, OJ getting free from his trial being not guilty, his trial being innocent. That's some of the craziest shit I've heard since the release of P. Diddy's underground, parties, his white parties, and all the weird shit he did with his lubricants. That's the craziest shit I've heard since. Oh, fuck. Shut up. Alright, I guess let's do it. Let's put it through the matrix and the Cramer's rule. I really want to. I really want to know what it's all about. I really, really, really want to know what it's all about. But I really ain't getting shit for reach up in here. I appreciate you guys being here. I appreciate you, Dinah. I love all of you. Alright, it's a lot of work. This is really a lot of work, so let's go ahead and do this. That literally can't even change. Negative 125i1, so we have those two. Okay, let's put it in order. So we have, let's see, 125j, 125j, I0, minus, well, plus I1. Then we have negative 125j minus 500 plus 500 I2 equals 0 equals 0. And then in this last line, what do we have? Can you see that? Oh yeah, you can see that. In this last line, what do we got? We got negative 500 I2, I1, I2, I2. So we'll start with I1, 500 I1 plus I2 brackets negative 500 minus 300 plus 400j equals 0. So we only have one constant outside of our unknowns. That's it. That's entirely it. Okay, so we'll put him on that side. So equals negative 250j. And the others are zeros. Okay, we can go ahead and figure out our determinant. And of course, it's a 3x3 matrix also. I mean, are you kidding me? But that's fine. So what does our matrix look like? This is our matrix. So negative 62.5 minus 125j, 125, okay, and then 0. And then we have, that's our first line. Let's label them. 2, 3. Then we have 125j. We have negative 500 minus 125j. Then we have positive 500 I2. What is that? That's 0. That's 500. That's negative 500 minus 300, negative 800 plus 400j. Alright, that's our matrix. Alright, this is going to be crazy. It's going to be really crazy. So we have to put it into phasor form. Okay. It's going to be really crazy. Oh my gosh. This is This is not the best. This is definitely not the best way to do this. This is absurd. Definitely not the best way to do this. Oh shit. I still want to do it regardless because I just want to, I want to accomplish it. But damn, brother. That's a lot of work. That's a lot of work. Maybe not so much. I don't know. Okay, so we're going to have to do... So we can go ahead and convert this one into phasor form because that's going to be our first multiplication. So 62.5 squared plus 125 squared. Square root of that is 139. So 139. Try to use as little room as possible. It's going to take a lot. So 139.75 phase. Inverse tangent of negative 125. 125 divided by negative 62.5. 63.43 degrees multiplied by, so we're gonna have a multiplication and then a subtraction right there. That's ridiculous. Oh fuck. Okay, so the square root of negative 500, no, we don't need to do negative 500 squared plus 125 squared is 515. So 515 multiplied by 800. Wait, the square root of 800 squared plus 400 squared times 894. That's true? Wow. Those are big numbers. Phase, inverse tangent of 500. Wait, of negative 125 divided by negative 500 equals 14 minus inverse tangent of 400 divided by negative 800. 40. I can't do this. I don't think this is gonna work. I think this is gonna take me way too long to calculate because there's a conversion between rectangular and polar coordinates through almost every fucking step of solving for the determinant of this matrix. I mean, I'm telling you, brother, it ain't gonna happen. Okay, so let's just try to solve through like simple ass, linear algebra. Okay, so we'll make a relationship here. So let's just solve for, what do we have? We have I naught and we have a constant in I1. So using this equation, let's just solve for I1. We'll solve for I1. So, okay, so I1 equals negative 250 J minus I naught multiplied by negative 62.5 minus 125 J, all divided by 125J. Imaginary number. So negative 250 minus, okay, we're not going to consider that. Negative 250, and then we can't do a division either because we would have to convert it into, what the fuck, and then we'd have to convert it into the values. Well, that's not true. Can I not just plug it into my matrix? Are you kidding me? Let's try it. Let's see. So let's go to the matrix. Let's edit this matrix. We got a 3 by 3. Okay, so negative 62.5 minus 125. Imaginary number. What the fuck? You can't put an imaginary number in a matrix? Oh hell no. Oh, hell nah. That's the thing. This problem is really that long to solve? I just genuinely can't believe it. Okay, I guess it's, okay, let's continue with what I was doing then. What the, 40.6 degrees. minus, see, okay, and then I'm gonna have to convert it to rectangular form again. Okay, whatever. This is fucking absurd. 500, 500. Right, there's no angle. What, 500? Wait, so okay, so 707 point f whatever. Angle, no angle though, because there's no imaginary part, so 0 degrees. Right, okay. That's literally just the first. That's literally just the first. Okay, 125, there's no angle, so 125, 0 degrees, multiplied by 125j multiplied, well, okay, so 125j, 125j. So 125 squared, just be 125 phase 90 degrees, right? 125j. I mean, that's the inductor, and it'd be 90 degrees, wouldn't it? Okay. Well, 125 multiplied by the magnitude of this equation, so multiplied by square root of 800 squared plus 400 squared equals 894 times 894 angle 90 degrees minus 90 minus inverse tangent of 400 divided by negative 800. That's what we got here. 116 is positive 0.6 minus fuck me, okay. So I did that this way. 500 times 0 is 0. And that's just it. Okay, 0. Alright, cool. And then 0 multiplied by this next function is just 0. Okay, so maybe this isn't as tough as I thought it would be. But then also I have to calculate the determinant with the constants plugged in also, which are mostly 0. So that won't be a big deal either. Okay. Now this equals, so 515, okay, 515 times 894. I mean, these are huge numbers. I don't know if I'm doing this right. So 139.75 phase 63.43 multiplied by, so now 707, it would just be that. And then this one would be, so cosine, that's such a large number, that can't be right. 40.6 minus 707. That just can't be right. There's no fucking way. What did I do wrong? Right, so this multiplied by, I mean, perhaps, yeah, what did I do the wrong one? That multiplied by that, so square root of 500 squared. Come on, brother. Come on, brother. Come on, brother. Come on, brother. Squared motherfucker. Okay. 500 squared plus 125 squared. Okay, 515, huge number. That multiplied by the square root of 800 squared plus 400 squared. Yeah, that's it. Why is that such a large, okay, that's a huge number. Minus 707. Well, wouldn't it be because there's no other portion of it? Fuck you guys. Holy shit, man. I'm trying to do it. I'm trying to get it done. I appreciate y'all being here, though. I'm trying to get it done. It's just a little too much maths. Like, honestly, this is crazy. So much time required. So if we were to convert it back, wouldn't it just be 707? There's no imaginary part, and so it would just be cosine minus that. So cosine, sine, and then what do we want? We want it back into that form? Yeah, pretty much. Yeah, that's what I did. Magnitude multiplied by that to get that, and then that's your remaining value. So 3.48 E 1, 2, 3, 4, 5. Holy smokes. E5 plus would be 1, sine 0 would be 0, and so it'd just be this multiplied by this times sine of 40.6 degrees. 2.99, 1, 2, 3, 4, 5, E5, J equals 125 degrees 0. Oh, and I still have to multiply that. Oh, shit. Alright. Alright, it's 11:40. How long have I been going for? Hour 42? Oh, man. Alright. You know, I think this is where I'm going to need to call it. I really appreciate you guys being here. Sorry I have to cut it out early before I even solve the fucking problem, but this is just ridiculous amounts of math. Perhaps I'm missing something and there's a much quicker way for it to be done. I will figure that out and I will come back to you because this is a disgrace. Alright, until next time, I love you guys so much.